Okay, well, welcome to my presentation. Today we're going to be talking about moving a monolith to reactive, or more specifically to microservices, and about how it's really all about architecture. So my name is James Roper. I work for Lightbend. I'm the tech lead for Largom, which is our new microservices framework. So today we're going to look at first of all, we're going to identify the pitfalls of monolith conversions. We're going to architect reactive solutions to those solutions. We're going to see Largom in action. So if you came here to see Largom, this is the right place to be. However, the stuff that I'm talking about today is not at all specific to Largom. So even if you have no intention to use Largom or using something else, it'll still be helpful. And we're going to see some live coding, which hopefully will be fun. So, Largom auction. This is a new online bidding website that I've created. So, at first, it's an eBay clone essentially, and at first I was, trying to get it done really fast. So I just did it as a monolith in something. And then I decided, I went to a conference and heard that microservices are all the rage and that everything has to be microservices, and that my auction website would not be successful if it wasn't microservices. So I converted it to microservices. And now that I've done that, it's going to overtake eBay. So it's going to be awesome. You guys should all use it. So this is a simplified view of what part of the system looked like when it was a monolith. We had a user that talked to the system through the controllers, through an MVC controllers, and then they would go and talk to some components. Let's say they were implemented in just as kind of Spring components, so there'd be method calls on the item model and on the bidding model. And so when I converted it to microservices, so first I got rid of the monolith, and now I had all these kind of classes that had nowhere to live, so I decided to make those services. The MVC controllers kind of became a web gateway, and then the item model and bidding model became the item service and bidding service, and I used REST to just call out to those in the same way that this used to be done from the MVC controllers. And so I did this and tested it in development, and everything was working. And then, because I converted it to microservices, the system started getting really popular. People started using it more because microservices are awesome. And things started to go wrong. So the first thing, concept that I'd like to introduce is the concept, things went wrong because before I had one monolith. Okay, and so keeping that one monolith alive required doing certain things, but it was fairly simple to run. Either it was running or it wasn't. But in microservices, you have many moving parts. What used to be one monolith might now be 3 or 10 or 100 different services. And so because there's more moving parts, there's a higher chance for failure. The more services you have, the more likely at some point something in the system isn't going to be working properly. There's also more chance for inconsistency. So when it's just one service, you can just exploit the fact that everything's kind of running locally to synchronize state and to ensure things are synchronous. So on the topic of synchronous, in my solution, you may have saw that I was using synchronous communication. So synchronous, as a word, it's an adjective. It means existing or occurring at the same time. So typically it's request response. Okay, so the client makes a request, server sends a response, such as REST. REST is an example of synchronous, and if you read Roy Fielding's original definition paper on REST, you'll see that it's like the number one requirement that he has is that it's REST request response. But for it to occur successfully, both systems must be responsive at the same time. So you can't make a request on a server that is not currently running and expect to get back a response. It has to be running at the same time that you make a request. If you go down before it sends you a response, then again, it's not going to succeed. You'll never get that response. And so you can see here, I've used synchronous requests. This is if I'm viewing an item, I'm going to make a request to get the item and get the bid history. At this point, I'll show you actually the system running. So I've got some great things here. Oops. Login is pretty simple. You just select who you are from a list of users. It's quite secure. So John Smith is going to create an item, some item, and some description. And it's going to be, this bid will last for, auction will last for 30 seconds. So here we are, we've created it, and we'll start the auction. Okay, and now Mary Jones will log in, and she'll bid $5. You can see that's successful. It starts at 50 cents because that's the increment, but it'll go up to $5. So if Bob comes and places a bid of $2, that will be accepted, but it's automatically outbid by Mary, so it's now up to $2.50. Bob then decides I actually want to bid $10. That's accepted, and because Mary's maximum bid was $5, it's now up to $5.50. And this auction lasts for, well, the auction is due to end now, so we hit refresh, and now it's over. The final price was $5.50. So in viewing this auction page, you can see I need both the details of the auction as well as the bidding history. So that's the situation here. Okay, but as I said, because I converted it to microservices, the system is now under very heavy load because everybody says it's so awesome. And at some point, my bidding service started to get slow. So what does that mean? Well, because my web gateway is making a synchronous call on the bid history to get the bid history, it can't send a response until the bidding service has also responded. So it effectively makes it slow, even though it's actually not under heavy load itself. And so my user is unhappy. And we can see a demo of this. So I'm going to simulate a slow system by inserting let's make it 15 seconds. Inserting a delay of 15 seconds into my bidding service. And so this is implemented by a filter. And if we go back to my auction page and I hit refresh, you'll see it takes some time to respond. Now, of course, what happens when, let's say the auction wasn't over yet, but it's going to be over soon, and I'm Bob and I want to see, has somebody outbid me yet? Okay, there we go, it eventually loaded, I'll do it again. And so what do? I keep on hitting refresh. And what does that do to my bidding service? Keeps on sending more and more requests, they build up, and the bidding service gets worse and worse and can't sort the problem out. Of course, it's just an artificial delay, so in this situation it's fine. But the first pattern, I'm going to introduce 4 patterns for building reactive microservices today. And the first pattern that I'm introducing is circuit breakers. So the idea behind a circuit breaker is that it's a gate that opens in the event of failure. If you've done electronics, you know there's circuit breakers there, and that if you go and short 2 wires together, the circuit breaker should break the circuit and prevent you from killing yourself. The same happens with circuit breakers. It prevents the system that's under heavy load or that is failing from their situation being exacerbated. Circuit breakers also usually include timeouts, so it's not just if it's returning a failure status, it'll also time out if it takes too long. Protects already failing services. And another thing is that it allows the consumer to fail fast rather than having to wait. every time for it to not return a response, it can quickly say, do something in response. So let's have a look at what circuit breakers look like. So Lightbend actually comes with circuit breakers out of the box. It's just that I disabled them. So this is in the web gateway. So I'm enabling it now. And so, by the way, Lightbend uses hot reloads in the back, so you can see after I do that, you get a reload there that's on the play application that's been used during the web gateway. So now, if I hit refresh, the first request, of course, it's still going to take a while to respond. As with the second request, I've set the threshold at 2, but then after, and the timeout for these things is 5 seconds. And so now you can see it's timed out, and if I keep on hitting refresh, it's now blocking the call altogether and never sending it. And so I get a response quickly. But this is actually a bit worse. We're now in a worse situation. If we go back, we can see now that the circuit breaker is broken, the web gateway effectively blows up and starts returning errors to the user. And so the user's not happy. In fact, before they got their response slowly, now they don't get their response at all. So what are we going to do about this? So the second pattern that I'm going to introduce is failure recovery. So we can work around failure by degrading. Not every call that we do to our back-end services is going to be necessary to render every page. So in the case of the item service, of the item page, now you're going to want to actually see the item. So we're not going to do any failure recovery for the item, because what else are we going to show if you can't view the item? But maybe the bidding history isn't so important. And so we'll simply render no history in the case that in the case that the bidding service is not responding. And so that will ensure that even when our bidding service is slow, that our web gateway is still fine and the user's happy. So let's have a look at that. Here's my play item controller here. And this is making the call to the bid service just here. So you can actually see here I make the item service call, the bid service call. These are return futures, so these are both done in parallel, and then I combine them here with the Java completion stage API. So what I'm going to do on the bid service call is I'm going to use this exceptionally, which is a weird name, sort of. Recover would be a better name, but that's the Java API. And so when we get that error, this gives us an opportunity to do something else instead. We'll log it because we probably want to know if it's failing. And instead of just, and we'll just return an empty list for the bid history. We're using this Java library called pcollections, which is an implementation of the Java collections API, which are persistent, i.e. they're immutable, and changing it that just returns a copy doesn't actually change the collection. And so let's have a look and see what happens now in our failing service. So the bid service should still be slow, and so our circuit breaker hasn't timed out yet, but now we see it after the service breaker times out. Again, once our circuit breaker kicks in, we should be able to load these things quickly, and now we are. So, whoops. So, of course, we can't see the bidding history. Bit of a problem. Probably more of a problem is we can't see the price. If you're waiting to see if you've been outbid at the end of the auction so you can place another bid, you probably want to see that final price. We'll address that later. So back to our presentation. So another problem that I want to talk about is that failure can lead to inconsistency, and this is a much bigger problem than simply not giving the user a bad response. So you saw when I did that first initial flow before that I hit the start auction button to start the auction. That's implemented. The user sends a post to the web gateway, which posts a start auction call to the item service using REST. And currently the way that's implemented is the bidding service then also needs to be told about the auction so that it can accept bids and it can know what the reserve is and what the increment is and when the auction finishes. And so currently the item service, then once it's received the start auction command, then tells the bidding service to start the auction. So what happens if when it does that, the bidding service is down, or its database is down, or it's just not responding? What does the item service do then? Well, let's find out what it looks like. I'll create another item. We'll probably want to play with this one for a while, so I set it to 30 minutes, auction duration. And so we hit create item. And so now we're going to try and start that auction. Actually, before I do this, what I will do is I will fix that initial delay, that delay, and instead I'm going to kill the auction service. So I've got another thing in the bidding service that if that's true, it won't even start up. And so we can see here when we restart, it doesn't start properly and it's not very happy. So now if we try and start an auction, we get an error, okay? Now, of course, what might happen then is the user will go back to the previous page, they hit refresh, and they find, oh, the auction started, it was created, it's okay. So the auction started, and then Mary Jones comes here, and she finds it, and she decides to bid $10 on it. And she places a bid, and of course it doesn't work because the bidding service isn't up. But let's say the bidding service recovers, somebody realizes that they accidentally had a kill equals true in their configuration, and so they fix that. And so then Mary places her bid, and it says the auction has not started. Now, how can that be possible? Because you can see there it says the auction started 46 seconds ago. And the problem is that the bidding service doesn't know about this auction because the call that told it about the auction failed. So when we post that bid, the auction service is confused because it goes, well, I don't know about that auction, and the user's not happy. So, inconsistency from failure. The problem is that synchronous, remember that synchronous means at the same time. In other words, both systems must be up at the same time in order for it to work. Communication about updates is dangerous. In a monolith, you just use transactions. So the item service goes and it creates the item and then tells the bidding service to start the auction, and that will be done on the same transaction and it's all happy. But transactions can't span service boundaries. You don't want, you certainly don't want to try and use two-phase commit, for example, across an HTTP request. So pattern 3 is asynchronous messaging. Asynchronous is the opposite of synchronous, means it doesn't have to happen at the same time. The receiver can process it at the message at a completely different time to when the sender sends it, so they don't have to be up at the same time. Asynchronous messaging is also perfect if you already persist events. So, because then you can use that persistent events as a source of messages. And we're going to see an advantage of this very soon. So, who here has heard of, I'm guessing you've all come across event sourcing. I know Jonas talked about it in his keynote, and it's probably been quite a theme here. Event sourcing is great, and we're going to see a very good reason as to why. But after we've implemented this, what's going to happen is instead of doing that post-start auction there, we're going to turn it into a message that's just going to send this auction started message. It goes one way, they don't have to be up at the same time. So then if the bidding service is down, item service is still going to be happy because it doesn't even care if the bidding service is up or down at the same time. Then when the user comes later and the bidding service is back up and posts a bid, the bidding service will be able to process that message and be able to respond accordingly. So, what we'll do now is we're going to go to our item service. So now, Lagom 1.2, which the release candidate is out, supports publishing messages via Cassandra. Actually, let's have a look at what happens in the start auction message. So this is what a Lagom action service call looks like. You can see here's the start auction where we've got some authentication happening. We get the entity ref for this item ID, and we ask it to start the auction. So this is sending a command, and then we do something in response. At the moment, what we're doing in response is we're calling start auction on the bidding service. So let's get rid of that. We don't want to call start auction on the bidding service. If we go into the entity, we have a few different states here. So there's different behaviours for different states. So when the auction is created, but not in an auction, it's in the created state, and this is the behaviour that we have. You can get the item, you can start an auction, so this is the command here on the left for start auction. And what happens when we start some auction is after doing some validation, we then persist this auction started event. And notice the symmetry here. A command is in the present test. It's an imperative. Start this auction. The event is in the past tense. Auction started. And so we persist this event, saying when the auction started. And then we also have an event handler, and this describes how the event that's just been persisted is going to change our state. So when we get an auction started, we change the state, and we actually go into the auction behaviour at that point, which then has a whole different set of command handlers and event handlers. So, now that we've persisted this event, we now want to send this event somehow to the bidding service. And what Lagom lets you do is get that stream of events. So back in our item service imp, we've actually already just in our service descriptor said that we publish an event stream. And we've called it item events. I'll actually show you what that looks like in the descriptor. So we're saying this describes everything that the item service does. So we've got some service calls which are implemented using REST, and then we've got a topic, and this is going to publish things to Kafka. So right now, we're using this tagged stream with offset to implement the topic. Now, when consuming this stream, when the service starts up, it's going to start this stream, and we don't want to publish any events because all these are persisted events, and they're all events for the entire life of the system. We don't want to, every time the service starts up, republish all the events from the history. So what we use is we store an offset, and we only publish the events. And when we start up, we only get the events since the last offset. And so when you publish a stream of events out of Lagom, it will ask you, can you give me a stream of all events since the offset that I last saw? So what we're going to do is look up the event stream for that item. So another thing here is these tags. Lagom actually supports sharded read sides, so the events actually get a tag, and so we're going to start this up for all the tags. And Lagom actually ensures that these streams are distributed across your cluster evenly. So get all the events for this tag since the offset. We're going to filter it because we only want to publish at this stage the auction started events. And then for each event, we want to map it to convert it into our auction event. sorry. I already did that one. So then I've already written this method to convert it. The conversion method actually goes and gets the item to be able to look up all the details that it's needed for the event that it's publishing. And then we convert it into a pair of the event and the original offset. And so when we send this back to Lagom, it sees that it's able to take that offset, and once it's sent it to Kafka, persist that offset so it knows that this event's been persisted, so next time when it starts up, we can start from that offset. So now we've published the events out of the item service. Let's go into the bidding service and consume them. So we're just going to do this in the constructor of the bidding service. You can see we invoke that item events topic and we call subscribe, and then we use at least once. So Kafka messaging is at least once, and the way this works is that we need to supply a flow that takes the event and maps it to done. So whenever we emit done, then it can handle that offset. It can commit that it's received that event. And so we create that flow. We then check to see if it's the type of message that we want. Otherwise, we're going to ignore it, because in future there might be new events that we don't know about and we don't want to fail. Cast it to that event. And then we create a new auction from the event. Then we will go and get the entity ref, and we'll ask it to start the auction. And so this now will start the auction on the bidding side. So now if we go back to our demo, we hit refresh. That's refreshing. I think our bidding service is currently dead. So let's unkill it. Oh no, it's not dead. So let's place a bid on it. Actually, no, yeah, that's right. Before we tried to place a bid and it didn't work. Now we're trying to place a bid and it does work. Now that start auction command failed before. And we remember that the bidding service failed. It said that auction hasn't started. But now we haven't done anything. We haven't created a new auction. We haven't told it to start again, but it has started again. How did it start? Well, because remember, this isn't, we're not sending this event when we handle the command. It's consuming the events out of the persisted history. So that event was already persisted in the history. So when it started up, when the item service started up, it went and got that event out of the history and published it to Kafka, and then the bidding service received it. And so this is one of the things that shows what's so good about using event sourcing, is that when you have a problem like this where, we didn't have, something wasn't running and we used synchronous communication, you can then fix it and it'll go back and basically fix itself, because every event that happened is there, persisted, ready to be handled. Okay, so before we saw a problem, when we just degraded the item page with the empty bid history, we saw that the price was $0, and that's a problem, because especially if it's getting to the end of the auction, which is when, let's say Justin Bieber decided to sell his sunglasses, and so you've got a million teenagers there who wanted to buy it, and it gets to the end of the auction, and they're all hitting refresh, and the bidding service goes down because it can't handle the load, and they're still hitting refresh, and they're saying it's still they're saying $0. Which is not what they're expecting to see. They might tolerate not seeing the bidding history, but they want to see that price so that the one who's currently winning knows if they need to bid again to outbid the new bid. So in the case where the bidding service is blown up, the web gateway is still able to respond, but they see price of 0 and they just get confused, the users. So we saw an example of that already before. So the pattern that we're going to use now to solve this is called denormalization. So the idea is push important information, so the bidding history is not so important, but the current price is very important. And push that important information to other services. So that information could be important for system functions or important for business functions, as it is in this case where the current price is important. And then in those services, store that information duplicated. So the current price is known by the bidding service. We don't need to store it in a second place, but we do for the purposes of resilience. And this is also known as denormalization. So in a normalized system, all your data should only appear once, but we're duplicating it so it appears twice. So in this case, when a user posts a bid, a message will be sent to say the prices have been updated to the item service. And then when the bidding service goes down and the user goes to view the bids, and they do get item, get bid history, they'll see a price there still. So let's have a look at implementing this. So back in our bidding service, again, I've done some work ahead of time and created this bid events topic, and I've created this helper method here already. So very similar to publishing events in the item service, we get the event stream for the tag and offset. We filter it by only the bids we want to publish, and we're not only going to publish the bid placed events, so these are the ones that have the current price. We're also going to, while we're at it, publish a bidding finished message. We'll map those events. And then if it's a bid placed event, we'll cast it. And then we'll convert it to our service object of a bid placed. By the way, I'm separating, I've been very careful here to separate the objects that are used in the service call API from the objects that are used in the persistence API so that they can evolve independently, which is why the conversions are needed. You don't really want to publish your persistent objects directly. And then here's the handling for the bidding finish. And so back in my item service, I'm going to subscribe to that event stream. So we invoke the bid events topic and call subscribe. We create a flow to handle it. If it's a bid placed event, we update the price of our item by submitting this command, and I've already implemented that command, and the bidding finished handling. So now, when we go back here and hit refresh, make sure it's all happy once it's reloaded. So everything's working now. We can see the price is currently 50 cents, bargain for Justin Bieber's sunglasses. Auction ends in 12 minutes and everybody's hitting refresh on their browser, and then the bidding service doesn't like it, so it dies. Yeah. So it goes down. We can see we can't see the bidding history anymore, but we should be able to see the current price. Now this problem actually happened to me before, was the item service didn't come up properly. So let me just make sure that that's going to work. and the current price is now 50 cents. And even though we can't see the bidding history, we can see that this event has been asynchronously published by the bid service at some point and handled by the item service, and everything's all good. And so, and I'll show you in the item controller how that's handled. So we actually, in that we look at the current price that's already in the item service. Well, we get the current price from the bid history, but if the bid history, if it's still 0 there, then we let the item price, we fall back to the price from the item. Or if the current price, if the current price is greater than the item price, then we'll use the current price from the bid history. But if it's not, then we let the item price be used. So, what have we seen today? We've seen that you can't just simply, when you convert from a monolith to microservices, you can't just simply get rid of your monolith but have everything kind of the same with all the same kind of method calls replaced with REST calls. We've seen that failure and inconsistency must be managed. Otherwise, you end up in a situation that's worse. So with a monolith, if it goes down, it goes down. But when you've got microservices, when something goes wrong, things can get a lot worse. So we saw 4 patterns. You should use circuit breakers. You should use failure degradation because, as I said, there's a lot more higher chance that something somewhere is going to have failed. And if you don't want your system to pretty much always be in some sort of returning errors, you want to be able to degrade gracefully from those errors. You should use asynchronous messaging, especially for any updates posted between services. And you should use denormalization. So the next steps, you can go and check out Lagom, lagomframework.com. The version 1.2.0, RC1, has the message broker support, so check that out. If you use 1.1, you won't find the message broker support. You can also check out this presentation. In fact, everything in that GitHub repo is there for you to be able to give it yourself, including the IntelliJ live templates that allowed me to just make code magically appear. So thanks for that. Anybody got any questions? Yep. Testing. So what sort of testing? Yep. Yes. So, okay, so there's lots of different things that you might want to test. A very important thing to test is your persistent entities. So you'll send commands to them, and those commands need to trigger various events, various state changes, and things like that. Lagom has a persistent entity test kit that lets you do that. You can say, send a command and then assert that these events were emitted, assert that the state's now this, check that the behavior is correct. And that's just pretty simple to use from JUnit. Another thing you may want to test is the service itself, the service call itself. In that case, you can start up the Lagom system. You can inject a kind of a mocked persistent entity context to be able to check that the right service calls were emitted when things happen. Or you could extract out, kind of abstract over those things so you don't have to start up a whole system. There's a few options there. But yes, generally it's just JUnit testing. Another thing is Lagom also has support for being able to start up a whole system, multiple services in a test, and then you can go and invoke things, and it's a bit more limited than normal unit testing. Like it starts it up before all your tests run, so your tests have to go and clean up after themselves and things like that. But there is support there for doing that kind of integration testing, and again, that's just from JUnit. I can't, the lights have, yep.
I have a question, maybe it's a statement, maybe you can comment on this. It has to do with denormalization.
Yep.
In other talks and other things I've read and everything, there's been like, isolation and do one thing and one thing only do it well.
Yep.
And denormalization sort of seems to fly in the face of those two things. Can you talk a little bit more about
Sure. So the question is about denormalization and how that gets reconciled with do one thing and one thing well, and I'm assuming you mean, well, if I duplicate some of the state from here, then that's kind of means that this is now handling not just its own things, but things from other areas. There's actually already some denormalization here, so the state of the auction should be stored at one place in the database. But we had the state of the auction being stored in the auction service, and then an auction start auction command was sent to the bidding service, or a auction started event was sent to the bidding service, and again that state was stored in the bidding service. So there's denormalized data there. In that particular case, the bidding service needs to know that data or that state in order to do its one thing that it's doing well. So the denormalization it doesn't necessarily mean that there's responsibilities being duplicated. The responsibility of the auction of the item service is to manage the life cycle of the item, and it's going to manage it through to when it's created and being edited, through to when it's under auction, through to when the transaction between the buyer and the seller is actually happening. The responsibility of the bidding service is while the auction is happening to manage all those bids. So for that start auction event, that's denormalized, but it's necessary in order for them to do their job. So as far as the item service holding the price of the current price of the bid, I guess it depends how you look at it. The item service needs to be able to, it's a responsibility of it to be able to show the current state of the item, and you could say that the current price is part of that current state, and so it's part of the responsibility. The other thing is, I didn't actually say what lagom means. So lagom is a Swedish word that means just right, just the right size. And it's really, it's kind of a way of life for Swedes. If you talk to them about it, I probably can't really explain it that well, but adequate, sufficient, just right. And we called it that to really make a contrast from this thing of microservices where micro kind of implies it's all about size. And it's not all about size, it's about having the right boundaries in order to achieve your job, in order for the system to be implemented. And there are lots of different competing concerns, like you want a service to be maintained by just one team, for example, so organisational concerns will impact what goes into a service and what doesn't. What your consistency needs is, so if you've got some strong consistency needs, then that has to be in one service. It shouldn't span multiple services. So the one responsibility is another concern. So one responsibility is important for ensuring, I guess, the simplicity of the overall architecture, but it may compete with some of the other concerns. And so rather than having a concrete, you must have this rule, it's more about taking the holistic picture and having just the right size for your things. So a microservice may have, for performance reasons or resilience reasons in this case, there may be some leaking of some additional responsibilities in there. But I don't think that's necessarily a bad thing, it's just a balance. Any other questions? If I call out it because I can't see because of the lights. Okay, well, thanks for listening, and yeah.